also, I am going to give you steps to find when constructing a confidence interval, which is one of our main topics. It's a topic covered in 6.1 and 6.2. This is technically for 6.2, but these steps will be followed for, I've got it here for both types of problems. This is the single most important thing that you should have in your notes to refer to when you're taking the test on the next test coming up. Some students said they didn't have enough time to do the previous test, and a lot of it is just being organizing and practicing and knowing what you're supposed to do. So list these steps. You can also write an example to go along with it. Whether it's the example I'm doing now, the example could be from the practice test. Technically, you're not supposed to be using the document for the practice test on the test. Even if you do use it, it's not a good strategy. It's not going to help you a lot because it's going to be really hard unless you know your problems really well. It's going to be really hard to match up problems. And so if you're relying on that too much, it's not a good idea. Here's what you want to use on the practice test is these steps. And if you need to reword them so they make more sense to you, that's fine. But these steps, and then maybe an example to follow. So you could find a couple examples to go with this, to put with this. It could come from the practice test. It could come from this PowerPoint. So step one, now I'm also going to suggest, I'm going to sit here and talk about these. I'll tell you when I'm about to go to the next page. You could also pause at the very end and write down. You could listen or you could write down while I'm talking, but you can also pause. So I'll let you know when I'm about to move on to the next page. So first you need to know either that your sample size is greater than or equal to 30, or you need to know if the population is a normal distribution, has a normal distribution. If the answer is no to both of these, stop. You can't do the problem. If it's yes to one or the other, you can proceed. Okay, then, and we're going to use this more on the next page, the sample mean, X bar, is the point estimate. We're trying to estimate the population mean. The sample mean is what we would call the point estimate. Sometimes I just ask that question, period. I don't ask for a whole interval. Then it's a pretty easy to answer. You just need the sample mean. Okay, then to proceed with this, you need to know if the population standard deviation is known. In some things that are well studied, you might know the population standard deviation. Often you don't. So if it is known, you're going to use the standard normal table to find what we call the critical values, which are Z sub C from the bottom. It's a little, the critical value table is a little table. It's not the main table. It's at the bottom of the first page of that packet I handed you of the standard normal table. Look at the bottom and it gives you some critical values, which are called Z sub C. And then you're going to use this formula to find the margin of error. And then if your population standard deviation is not known, you can always calculate your sample standard deviation. It can always be calculated. So you would need to find your critical values then from the T distribution table, which is the second table. We would call the critical value T sub C, and you need to know what the degrees of freedom equals n minus 1, because that's something you're using to look this up on the table. And then there's a formula for the margin of error. So compare the two formulas. They both have critical values, but one comes from the standard normal table and one comes from the T distribution table. They both have standard deviations. This one's the population one when we know it, and this one's the sample one. And then of course n is the sample size. So I'm about to change to the next slide. If you need to pause so that you can finish taking notes and writing this down, feel free to do that. Okay, I'm changing. Okay, then you're going to find your endpoint. So actually I'm going to get to the picture here. We know that the point estimate is our sample mean, and then we just calculated the margin of error. So to get the right-hand endpoint, we'd add the margin of error to our sample mean to get this, and then to get the left-hand endpoint, we subtract the margin of error. That's our interval. We're predicting that our population mean is between here and here. Now it's just presenting your answer. So your answer would be written in interval notation. There's two ways you could actually write it, but usually the easiest way is interval notation, left-hand endpoint, comma, right-hand endpoint with parentheses on both sides. You have to have it written correctly to get full credit. This means everything between here and here. Everything between here and here. when you write it like that. Another way to write it is like this, where we are predicting the population mean to be between here and here. And then lastly, and again, at this point, if you want to just pause to get this all written, I'm going to, if you are asked to interpret your results, you would say, with level of confidence, whatever percent you were given, we can state that the population mean of whatever you're studying is between the minimum value, which is your left-hand endpoint, and your maximum value, which is your right-hand endpoint. So I am going to switch slides. So if you need to pause, do that, and I'll switch and do an example. Okay, read the example. We're going to start writing down what we know. You randomly select 16 coffee shops and measure the temperature of the coffee sold at each. So that's my sample size. N equals 16. Notice that's less than 30, so I need more information to even do the problem. Also, tip, if you're watching a video, you might want to just pause and write out what you can get from the problem with appropriate symbols. In other words, the sample mean temperature is 162.0 degrees Fahrenheit. You could be reading this on your own, because this is the key to doing these problems. Sample mean is X bar. So on your paper, you write X bar equals 162.0. With a sample standard deviation of 10 degrees Fahrenheit. What's sample standard deviation? That is S. S equals 10, not population. It says sample right here, but even if I took that word sample out, that whole sentence is talking about the sample, so no matter what, that's the sample standard deviation, because that's what that sentence is talking about. We are not given the population, we're given the sample standard deviation. Construct a 95% confidence interval, so C equals 0.95, for the population mean temperature of coffee sold. So we're predicting we got a sample mean, we're predicting the population mean. Assume the temperatures are approximately normally distributed. Oh, I needed that to even do the problem, because you either need to know that or you need to know that your sample size is bigger than 30. So right now we have, I'm going to go ahead and flip to the next slide. What do we know? We've already should have this written down. Well, we know it's normally distributed, and that's why we can even do this problem in the first place. These are all the things I wrote down. Since we do not know the population standard deviation, this is my point estimate, if I master that, and I'll use it a little bit later on. But since I do not know the population standard deviation, I would use the t-distribution table, and I need to know my degrees of freedom, which is n minus 1. My sample size minus 1 is 15. You go to the table, you look it up. So let's go to the table real quick. Here's a table. Look at degrees of freedom is 15. So go down the left-hand side to 15 and then go across. It's like the middle, 0.95, I think is what we're doing. So it's 2.131 is my critical value. So that comes from degrees of freedom and confidence level. 2.131 came from reading that table. And then we're going to use a formula for margin of error. And this formula, I'm using an iPad. I usually don't. And some of you guys have reported to me that some of my formulas don't look right. There should be an equal sign right here. E equals T sub C times S times over the square root of N. We know T sub C, we know S, and we know N, so fill those in. There should be an equal sign right there. And then you're just going to enter this in your calculator. You can pause, you could try it. 2.131 times 10 divided by the square root of 16. And again, there should be an equal sign right here. It shows up on my computer, but not on my iPad, equals 5.3. And so this is called my margin of error, 5.3. So then I want to construct my confidence interval. So let me go to the whiteboard. Let me erase this. Okay, so I have my my point estimate is at 162. That's my sample mean. Okay, then I'm going to add my margin of error to that to get my left-hand endpoint, which would be 162 plus 5.2, plus 5.3, I believe it is. 0.3, I'm trying to do this from memory. And then over here, so if I get this wrong, I'll correct it in just a minute. 162 minus 5.3 is, I think, 150. I'm doing it in my head. So 100, if I get it wrong, we'll see the correct answer. But we're taking 100 x bar minus my margin of error. So 162 minus 5.3 would be, I think, 156.7. So we're predicting that my population mean is between those two numbers. So my final answer could be written like this. This and this, meaning that means everything between this and this. So how do we interpret that? We need to know what we are studying to be able to interpret that. Let's see, this is just on my PowerPoint, how I wrote it out. And again, I'm missing symbols here. That should be minus, minus, minus to get that, plus, plus to get that. There's my answer in one way. This is the way I usually do it because it's easiest. And then here's a picture of what I just drew. And here's the interpretation. We were told with 95% confidence level, what were we measuring? You can say that the mean temperature of coffee sold is between 156.7, add your units, degrees Fahrenheit, and 167.3 degrees Fahrenheit. And that concludes that example. I'm going to do another example we have on the next video.